Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of Module 5 on Engineering Geology of Dams and Forces Acting on Dams. In our previous discussion, we have elucidated different type of dam based on material used, based on design and function. In this lecture, we are going to elaborate about the arch dams and classification of dams based on usage and application, as well as technical specification. In addition to this, we are going to elaborate in brief about the concept of forces acting on dam. In this lecture, we are going to elaborate about arch dams and classification based on usage and application, function, technical specification and concept of forces acting on dam. In this lecture, we are going to cover about classification and features of arch dam, classification based on usage and function and applications, classification based on technical specification and concept of forces acting on dam. Friends, in previous discussions, we have already discussed about arch dam and some classification related aspects of arch dam. If we are going to divide arch dam based on thickness of base, that is the base width, and structural height, then we can divide arch dam in three broad categories. Thin dam based on B by H ratio. B is representing width, H is representing structural height, is less than 0.2, and then medium type or moderate type of thick dam ranging from 0.2 to 0.3, and thick dam has more than 0.3. Based on radius and angle of arch dam, the arch dam can be broadly divided in three categories, namely constant radius arch dam, variable radius arch dam, and constant angle arch dam. In addition to this, we can add fourth category based on curvature, single curvature arch dam and double curvature arch dam. Beside this, we have already discussed based on the number of arches, mono arch dam, bi arch dam, and multi arch dam. So one by one we are going to elaborate about constant radius arch dam and variable radius arch dam, then constant angle arch dam in brief. As far as constant radius arch dam is concerned, constant radius arch dam is a dam in which radii of the outer side curve, which is known as extrados, and inner side, which is known as intrados wall. The extrados side having constant radii, however the intradot side having variable radii. Therefore, the overall look of the structure is close to the triangular face. If we are going to measure from this point, then all the radii for this part extrados is the same. However, in case of intrados, this radius may be more, this radius may be more, this radius may be less. So in this way, this varies in case of the constant radius arch dam. This dam has two walls, estrados and intrados, and the estrados is representing centers of all such circular arches in outer side zone and filled in one vertical line. In case of the intrados, that is the inner surface, showing decreasing radius from top to bottom as the thickness of this type of arch dam is increasing with respect to depth to counter the increasing habit of hydrostatic force. Next type of dam is a variable radius arch dam. Opposite to the constant radius arch dam, the variable radius arch dam, you can see this portion is a curved in nature, this portion is not curved in nature. So this is going to show this type of an arch dam in which the radii of estrados curve and of intrados curve may vary at various elevations, that the maximum at the top and minimum at the bottom side. Focal point of different curve rings are not lying on a similar vertical line, and it requires 58% concrete that used in constant radius arch dam. Means if in case of the constant radius arch dam we are going to use 100% concrete, then in this case we are using only 58% concrete to save the concrete. This type of, in which condition this type of dam is suitable, so such dams are recommended for V-shape valley only. In case of the constant angle arch dam, we are going to elaborate in this way. The constant angle arch dam is a type of variable radius arch dam, a special case of variable arch dam. This is type of variable radius arch dam in which the central angle of horizontal arch ring is of the same magnitude at all the elevation, and volume of concrete required is minimum when the central angle is having value of 133 degree 34 minutes. In this type of dam we are going to use minimum concrete at 42.6% or approximately 43% of concrete used in the constant radius arch dam. So this type of dam, constant angle arch dam, is going to use minimum concrete and going to save. So this is the benefit concerned to the constant angle arch dam. In addition to this, we are having classification as a single curvature arch dam and double curvature arch dam. In double curvature arch dam, as we are going to see this double curvature arch dam, we have good example. As the name indicates, it is having doubly curvature nature, here single curvature nature, and we have good example Idukki Dam in India, in South India. Similar to the classification based on design and functions, the sum of the supportive dams we are going to categorize as buttress dam, as composite dam, as beer dam, as barrage and coffer dam. The buttress dams are massive, thin and arch slabs or flat slabs supported by vertical bars or buttresses. Buttresses is utilized for the support. The slab having upstream slope bear the water thrust, while the buttresses going to support by acting normal to the plane of slab, take the load of the headwater region to transfer to its foundation area. The steel beams or girders placed between the buttresses prevent their bending as a extra precaution, extra measures. Advantage: buttress dam are hollow and less costly, and it can be used to provide extra support to the main project. Here you can see this wall in case of buttress dam having support of this buttress. This support is going to transfer the thrust coming from the water to the ground. This may be plain, this may be curved also. You can see this wall may be curved also, and the same function. Disadvantage: it requires more for work than a solid concrete dam required, because due to lot of complications, you have here lot of complications pushing these girders and others, and it is more prone to the deterioration. It requires repetitive maintenance and management, and the life of dam is less as compared to the other structural dams. You can see the view. Next type of dam is a composite dam. As the name indicates, if a dam is made up of partially earth dam or rockfill dam and partially concrete dam or masonry dam, then we are going to recognize this type of dam as a composite dam, and good examples we are having here. 4600 meter long Hirakund Dam located in Orissa state of India. Next is the Bear. Bear is a small gravity type of dam, very small in dimension, but the structurally same as we are going to utilize in gravity dam as overflow. A Bear is a small overflow type of dam and covers whole channel as a barrier. It allows water to flow from the top of the structure. Due to flow of water, there may be some erosion and abrasion also, so avoid abrasion and cutting of the material. Generally, this place is we are going to put some wood, some steel or some metals or some concrete to avoid deterioration of this head. You can see this head. So water is allowing to flow, either water is flowing from this head. Sometimes the interior design also we are going to make. Here water is entering in this side and going toward the downside. Next type of dam, that is a small dam, a barrage. A barrage is a barrier like dam built across a river, but it has no fixed reservoir. It is very small, only utilized for irrigation and others, or divert a part of river through network of canal, especially for the facility concerned to the irrigation. We have good example in India. The Farakka barrage across Ganga river in West Bengal, India, is an excellent example of barrage. Then coffer dam is a very important dam, and this coffer dam is a temporary enclosure to keep out water and soil from the site through dewatering and facilitate construction of the permanent dam project. This type of dam we are going to construct at very initial stage to facilitate construction of main project by clearing the site through diversion of the channel, as well as this dam is utilized for transportation of material, movement of the persons working for the main project, and other facilities, machines and others. After completion of the main project, generally we are going to destroy this coffer dam to clear the project in full phase. Various type of coffer dam we have designed, and you can see the number of coffer dam we are having based on the design and others. In addition to this, that is not concerned to the water, that is concerned to the waste material other, we have tailing dam. Therefore, in initial stage we have defined the dam and view of materials. This tailing dam is made up of concrete or earth-filled dam to retain or store the tailing or slurry as a product of mining, or some domestic use, or from some tailing concerned to the some ore industry, etc. Similar to the tailing dam, we have fly ash pond dam. Nowadays it is a very critical problem to stabilize fly ash coming due to burning of coal from the thermal power plants. Huge quantity of fly ash creating lot of problem and cover large area. Therefore, we are going to put this fly ash as a material in ponds in wet condition to avoid air pollution, and to stabilize this large pond generally need embankment dam, and this structure of the embankment dam to protect the wet fly ash is recognized as fly ash pond dam. In dam we have various components. We have already discussed different elements of the dam, in which one of the special structure is a spillway. Spillway we have already discussed, opening that discharge water from upstream to downstream type. And this is the most essential structure required for proper functioning of the dam, and this ensure about the proper functioning of the dam, and it means the release of flood water or excess water without causing any damage to dam is facilitated by spillway. The spillway has three parts: head structure, discharge structure, and terminal structure. The head structure function is a provide water inlet being provided with guided valves, and the bulkhead in case of the discharge structure carries the flow from its upper reach to the lower part, and the terminal structure act as a outlet or discharge to the tailwater. The spillway has some gate. It may be plain type, it may be radial type. These about technical based, application based, material based classification of dams. Now, as per the international body is called International Commission on Old Dams, and USBR, the dams can be categorized in three categories based on height: low dam, medium dam and high dam. The low dam having height of less than 30 meter. However, the high dam having height of more than 100 meter. In between these two, medium dam ranging in height from 30 to 100 meter. In addition to this, we have other terminology based on height only. The dam can be divided as major dam or minor dam. If major dam, then the dam should have height more than 150 meter. If minor dam, then it is less than 150 meter. Similarly, large dam and small dam. Large dam, all kinds of dam having more than 50 meter height is recognized as large dam. Less than 50 meter height is recognized as a small dam. So in majority of cases we have larger dam, we have major dam, high dam and medium dam. Low dam is for localized use, etc. So in this way we have covered about classification of dam based on different parameters. Any dam after construction feeling lot of problems due to different type of forces acting on dam. As per our descriptions we have already discussed, after completion of the dam and breaking of the coffer dam, then we are going to store water in reservoir. Suppose this is the reservoir and this is the headwater region upstream, this is the tailwater region downstream. Due to presence of water, there is some thrust acting or expected on this dam structure. Another force, this ground is experiencing some force due to the weight of this body of dam. And here also some horizontal forces, some vertical forces experienced by this structure. In addition to this, the surrounding condition also going to put some forces during earthquake, during change in season from high temperature to low temperature, due to siltation, due to erosion problem, and due to the wind blow, etc. So it is very important to analyze forces acting on dam which is going to influence the stability of dam. If we are going to see the different type of forces, the major forces acting on dam is the gravity dam, hydrostatic dam, hydrodynamic gravity force. If we are going to see the different type of forces acting on dam, then we can see the various type of forces concerned to this. On the dam, the impoundment of water exert pressure on upstream walls of the dam, tending to push the dam it downward, whereas gravity tend to resist it. Beside these, various forces acting on dam time to time due to change in surrounding condition and features of the reservoir. In fact, many type of forces act on dam due to water, thrust, uplift, load of sediments, dead weight of dam, wind pressure, seismic force, ice pressure, etc. Broadly, if we are going to see the major forces expected to act or acting on dam can be categorized as gravitational force, hydrostatic force, hydrodynamic force, wave force, shield pressure or shield force, then ice force, then seismic force or earthquake force, etc. These are some major forces acting on dam due to presence of water, due to body of the dam, and due to accumulation of erosional material, and due to change in temperature, formation of ice on the top of the dam, and due to earthquake or vibration caused by bombing and others from the enemy side. So in this way we are going to see this gravitational force. Here one brief I try to explain. This is the dam structure. The water is present here. This water is going to affect this dam in term of the thrust, horizontal thrust as well as vertical thrust in some cases. Similarly, the water present in tailwater side is also going to show some horizontal force or thrust. The weight of the structure is going to make some force toward the downward, and here the development of the wave on the superficial parts is also going to affect this part. So this expected force is going to affect the stability of dam, and dam finally fall under the failure, toppling or slide. This material I have collected from book written by Gangopadhyay. Yes, term as Engineering Geology, published from Oxford University publication. Then partially supports from the Engineering Geology book written by Well FG in 2007. Then we have partial supports from the textbook of Engineering Geology at elementary level by Kashabalu, NC, and then Foundation of Engineering Geology also going to contribute some part written by the Waltham T. If we are going to conclude, we can see that in view of base width and structural height, the arch dam can be divided as thin, medium and thick arch dam. In view of the radius and angle, the dams can be categorized in three categories: constant radius arch dam, variable radius arch dam and constant angle arch dam. In addition to this, based on the curvature, the arch dam can be divided into single curvature arch dam and double curvature arch dam. Idukki dam, we have good example about the double curvature arch dam. In addition to this arch dam and other type of dams, we have varieties of dam based on usage, application and support, in nature, as a buttress dam, as a barrage, as a piers, as coffer dam. Coffer dam is a very important because this dam is going to facilitate the movement of the peoples or technical and skilled person, then transportation of material, then diversion of tunnel, diversion of river for clearing the site, etc. Based on technical specification, dams can be divided as low, medium, high, major, minor, etc. Various kinds of forces we are going to expect due to impoundment of water behind the barrier and the weight of barrier structures along with some surrounding conditions and forces. Dear friends, in this class we have discussed about different types of dams, classification of dam based on uses and application, based on the curvature of the arch, based on technical specification, some component like spillway and gate, then about some of the major forces acting on dam due to impoundment of water and concrete structure of body. These examples we are going to take from gravity dam. Rest aspects of dam, particularly related to rest of the forces acting on dam, we will discuss in next class. Thank you for your patience. Thank you.